established in 1985. Completed nearly 38 years, and the college is offering 9 undergraduate programs and 4 postgraduate programs, and also college is offering full-time PhD program, and we have an excellent placement programs, and nearly 90% of the eligible students will be placed in various multinational companies, and at an average 85% of the student will pass in distinction and first class. They will have a good and Lord Alani situated in various places in the global, and they are helping us in building this college at an average for various activities.
பட்டதாரி. Good morning to everyone. Myself, Dr. Abid Naimuddin, Associate Professor in the Department of Electrical and Electronics Engineering and convener of this FDP. It gives me a great pleasure to welcome to all the participants on this Day 6 final session of this 1 week international level workshop on Introduction to Artificial Intelligence during 9th to 14th October 2023, organized by the Department of Electrical and Electronics Engineering in association with NI Labu Academy of GPREC, Department of Emerging Technologies in Computer Science, and Department of EC. Today, we will be having two sessions. One session will be taken by Mr. MK Pawan Kumar sir, the continuation of the previous session, last 2 days. And after that, myself, I will be taking one small session in the last after completion of this 1 hour. So participants are requested to stay online. The feedback link will be posted at the end of this session. So here today, uh, please fill the feedback clearly. So the name what you fill today will be considered for printing the certificate. That is the first point, important point. And second point, today you need to give two things. One is feedback about this workshop, and the second one is you need to attempt one quiz at the end of the giving the feedback for the workshop. So the participants whose attendance is more than 60% and who score 60% of the marks in the quiz, you will get the certificate to your register email ID. That is the one important point for today's session. So hence, I request once again all the participants to stay online. I will post the feedback link at the end of this session. Now, I am handovering the session to today's resource person, Mr. MK Pawan Kumar sir.
Thank you, Abid sir. So, uh, okay, I think you were able to see the screen also, I guess, if I'm not wrong.
Yes, yes.
Okay,
The
fine then.
desktop is coming, no
Okay,
PPT.
yeah, I just
Yeah.
turned on my presentation. Now I'll bring it up. Okay, so let us start from day before yesterday. So, and then we will join all the points and we will start our today's session. So, we started our session with what is machine learning. I'm sorry, just give me a minute. Okay, so we started our session journey with what is machine learning. What are the most used? I mean, any problem that you take would be any of these one of the categories like regression and then classification. So we have seen what are the different algorithms that kept or those are under these two different groups, the regressions and classification. So we saw like support vector machines, nearest neighbors, decision trees, random forest, bagging, boosting, all those things are available under classification. And then regressions, we have logistic regression as well as other things also like nearest neighbor regression, random forest regression. All those regressions are also present. So now we have taken couple of real-time problem statement like how many employees would stay back in the company versus how many of them leave out of the company, like from a organization perspective. And at the same time we have taken an example of latest generation data, that is your smartwatches and all, they collect data, right? So using which like we started predicting whether the person is basically tending towards an insomnia disease or not. Okay, the sleep disorderness basically. So that we did it. And then once we are okay, we are little comfortable about the terminology. I don't say that you are most familiar with machine learning, but I say that okay, you can now understand what is machine learning and how do we approach. So in which we saw little data patterns, basically like univariate analysis, bivariate analysis, like bivariate and univariate is a single variable data distribution versus two variable data distribution. That's what we saw. Like we were comparing one independent variable in association with the target variable. That all we saw, right? How that spread of the data is looking like with different graphs and all. Then we saw one of the important concept called correlation. So now by this, like you understood, okay, this is what is machine learning. This is the way of approach that we carry on with any problem that is given in front of us. Then it is not the end of life that we saw. I told you, and then yesterday we saw like how do you expose these models over an API. So we started with a normal API construction, which we named it as I love coffee. And then we started, we wrote some API methods. And then I've told you that there are like 4 predominantly used HTTP verbs, which are called get, post, put, and delete. So get is used for reading the data from the database and exposing it to the customer, and put is to update, post is to create a new record inside the database. When we say delete, it is like deleting some kind of records. It could be multiple or one or a single. So, and then using the concepts of those APIs, what we did is we wrote the similar kind of thing into our machine learning project, and we created a wrapper of API around the machine learning model such that it started exposing the model outside. And we utilized that API from a tool called Insomnia, and we started testing it by passing some data, and it was predicting whether an employee leaves or he stays back in the company. So, and finally we understood the cloud patterns. Once you have the API in hand, now you have to put it in some kind of a cloud infrastructure. So we understood the cloud terminologies a bit, like what is PaaS, what is IaaS, and then what is SaaS model, and then why we have to adopt cloud, the different properties like scalability, reliability, security, all these things. And then we also saw how do you convert a given uh, um, what do you say, a software into a dockerization. What is a docker is basically a container kind of a thing. Everything is holded into one container, your code base, operating system, everything, because we want to make our code independent of the platform that it is running with. So we bundled everything into a container and we started deploying that. So we even saw dockerization. So you can tell, okay, I know even a little bit of dockerization. But at the same time, you can start now exploring all these terminologies. But machine learning is not yet complete yet. Okay, so there are a lot of concepts, very, I mean, like huge concepts. It's basically an ocean, I can say. And these days, with the advent of more advanced machine learning algorithms and all, even machine learning is expanding a lot in different dimensions. Okay, maybe like any other time when opportunity comes again, we will learn about the advanced concepts. But there is one concept which is called time series analysis, which is very, very, very important, and also falls under machine learning. And this time series analysis, I don't know, someone from the session 1, they asked, is statistics useful in machine learning? That's what one of the question that came in, and Abid sir read that question out of your Q&A sessions. So I told yes, and now today is that evidence. Okay, time series analysis is like it's highly correlated or highly dependent on statistics. And if you know statistics, without even an algorithm, you can start solving a given problem on paper. That is the beauty of it. Okay, so with that introduction, let me open my presentation. And as is, so we will see quick theory and with a more practical in next half an hour to 45 minutes. Okay, so now coming introduction to time series. Time series is a set of observations on a quantitative variable collected over time. So what is the difference between a regression and time series analysis is basically both are continuous data. Just remember, these two are continuous data only. But in this time series analysis problem, there are different patterns and concepts and components involved into it, whereas regression doesn't have all those components at the same time. Even though both are continuous, one is predominantly dependent on time. So over the period of time, there is something that is getting changed in nature, change in nature. So that is the time series problem. Whereas in regression problem, there is no time attached to it. It is just like normal dependent versus an independent variable problem. But whereas coming to time series problems, you have a data and is in association with the time, and you cannot ignore that particular time. Okay, example, you have stock data, stock market, right? So I cannot ignore time from past 1 or 2 years. If you are analyzing stock market, the time or the date is very, very, very important while analyzing that data. Okay, so on one particular day, what is the behavior of a stock or a particular market or an industry? Okay, example, if you take an industry of aerospace, how is aerospace behaving in the last 1 week? So you cannot ignore the time. So that 1 week is time, which is very important. You can't get some kind of insight or meaning when I say what is the how is aerospace behaving, and if you leave the sentence there, you cannot get any inference. So how is aerospace industry behaving in last 1 week, last 1 month, last 1 year? Then that sentence make a sense. So that means the problems of time series cannot be inevitably separated from time. But it is not same with the normal regression problems. So I can say house prices in Hyderabad with respect to different attributes, the land category and all, and then the building sizes, the number of bedrooms, the locality in which it was present, the number of stories it has, whether it has got a parking lot or not. So if you take all these attributes, and finally you have some house price, maybe like house prices are like continuous function only. So I can take these attributes and we can fit this particular problem into regression, and this becomes multinomial regression. It's not a single variable, so it not be a linear regression, it becomes a multinomial regression. It could be exponential regression or something else. Okay, but it would be a multinomial regression. But this is a regression problem. Just see this difference. Okay, you don't have a time attached here, but the other problem you have a time attached. Example, again, one more example of a time series is historical data of sales. So your Amazon sale in 2022, what is the sales of Amazon? 21, what are the sales of Amazon? And if you further break it down, every month of 2022, what are the sales of Amazon? So something like that. So always there is a date and time relation between that, and at the same time you can take inventory, customer counts, interest rate, cost, everything, basically anything that you attach with time. Okay, now businesses are most often interested in forecasting of these series. Okay, reason being is, okay, till 2022 I know it. What if suppose I start a big billion day on Sankranti time frame? Okay, so what could be, or some Diwali time frame, so what could be my expected revenue incomes or expected sale growth? So how that will that can impact my income sources, that is return on investment. So how I can be benefited out of it. So if you want to forecast, okay, so time series is very, very important. Now in time series analysis, as I said, right, there are two things: regression analysis and time series analysis. Both are continuous. Time series analysis is basically a statistic technique. This is the first point that I told when I opened my lecture. Okay, so statistical technique that uses time series data for explaining the past, by explaining the past or forecasting the future. That means if you have a past data, so you can explain what has happened in the past using some visuals and all. At the same time, using that past data, you can start forecasting the future data. Okay, so now the prediction is basically a function of time. Maybe in the next 1 week how it could be, so you can predict it for 1 week, 1 month, or a 1 year also, that is 12 months, something like that. And no casual variable, there is no casual variable. In fact, like only time would be the common, but there is no casual variables. What is a time frame? Time frame is basically a window. Okay, if I say like past 1 week, that becomes your window. Okay, that is like very short. Okay, and then if you take a medium, I can take 6 months of data. Okay, maybe like 10 months, that's what, like 5 to 10 months I can say, take 6 months of data. And like, what is long term? Anything that is greater than or equal to 1 year, like 12 months or more than 12 months, like 24 months, that would be a very good data. And then what is trend is basically, it is a basic general literal English word. So if you see, there is a gradual increase of what I can say is, okay, let's take this COVID analysis. Okay, COVID which is like predominantly most frightened disease of over 22, 21, right? So we don't know what to do at that time. So every day when you open internet, I used to see a lot of predictions over the day. So when it started till date, okay, what people used to do, different statisticians, different computer science experts, they used to give the predictions. So how the trend is going. So in India, what is the trend? In European regions, what is the trend? In US or the west zone of the world, what is the trend? So trend is basically how the pattern is moving in future or in past. So whether it is growing, whether it is coming down, which is called declining trend, or it is stable, which is like a flattened line. Okay, so that is what is trend. And there is something called a cycle. So at every certain time, the same pattern again repeats, which is called the repetitiveness of that particular data again and again, which is called cycle. Example, people used to call it as waves. So first wave, second wave, third wave. What is that wave? Is a peak inside the data. So the trend would suddenly increase and then drop. Again, after 6 months of time, again there would be a peak increase and then drop. So this kind of pattern is called a cycle. So you can observe this pattern. Okay, for every 6 months there is something which is worst happening, and that is why the number of cases are increasing and then getting dropped. That is what a cycle is. So people used to observe that. And then seasonal variation, people used to say that from January to February you may have an impact again. Okay, so they used to tell that. That's called seasonality. So at some particular period or some kind of a seasonal impact over the data, so that's what we call as seasonal variation. Okay, random variation, it is like you don't have anything, but still the data behaves very odd or weird. So that's called random variation because of no reason. Okay, but these are like different terms that you have to remember: trend, cycle, seasonality, and then randomness. So we will find all these things inside one given data set. We will actually plot this inside different what do you say, data spreads, and then we will see them if time permits. But yeah, we'll see it. So it's difficult to forecast demand because there are no casual variables, and the components like trend, seasonality, cycles, random errors cannot always be easily or accurately identified. This is the fact of time series analysis. So how much of expert you be in time series analysis, it is not always what I can say is you cannot always predict the right values in future is always unrealistic. Example, yesterday you were telling today there is a match, right? So if you take the trend, so India is, today morning I was reading newspaper and I got to see that India is 8-0 unbeaten. So that means 8 times we won in the World Cups and 0 time Pak has won. That's what is the stat says. So over the period of time till I don't know from when the World Cup started, but at least like to my knowledge, the last 5 World Cup, 6 World Cups, we never lost against the team that we are playing today. So you can actually take those values, and then based on different parameters you can actually start predicting today's match output. Okay, so if you are interested, even before the match starts, like you can give the prediction saying that, boss, today who is going to win. So there is a stationary data, there is non-stationary data, and there is seasonal data. Okay, this is what we were telling. Stationary data is basically uh, there is a variable exhibiting no significant upward or downward trend over the time. Then that is called a stationary data. That means you are watching a variable, and that particular variable is not exhibiting any trend. That means like it is not either growing or not declining. So it is just constant. So that is called stationary. Non-stationary is either of the way. So it can actually exhibit an increasing trend or a decreasing trend. So you can see it here, like a significant upward or a downward trend. So nothing but an inclinated trend or a declinated trend. So that's called a non-stationary. Seasonal data, that's what I told, right? At regular interval patterns, there is something that gets repeated always. A pattern gets repeated. So it could be like a seasonals, and then maybe at November, December, most of the engineering student, they fly. That's what I hear most of the time for their MS and all. So if you take the past historical data of aviation and then see with in correlation with the student data, then you may see one kind of trend. Okay, most of the flyings that are happening in November and December is basically due to students. So that's what we see it, because they call it some fall season or something, and then the universities start opening the semester intakes and all. I think that is how they fly. So that is one more seasonal trend that you can observe. Okay, and now there are four different aspects of any time series analysis. There are many different time series techniques first of all, and then usually it is impossible to predict, tell like whichever technique is best suited for a given problem. You have to try everything, and it is almost the same thing when we learn the machine learning, right? You cannot tell one particular algorithm is always best. No, you have to try all the algorithms, and then basically based on what they say, that accuracy measures, you have to find, okay, this is my algorithm that I will choose, and maybe then you have to fine tune only that particular algorithm. Okay, so, and then it is customary to try out several different techniques and select one out of them, and then to be an effective time series modeler, you may be keep several time series techniques in your toolbox, like arima, sarima, and all those things. We will see it. Okay, and how do you measure the accuracy of a time series? Most of the time we take MSE, which is mean square error. Okay, mean square error is I think like I have given all the formulas here: mean absolute deviation, mean absolute percentage error. We call it as MAP. I think in today's session when I'm coding in live, so I'll be showing something called mean absolute percentage error, which is called MAPI or MAPE. And then and then mean square error. Most of the time people stick to mean square error, and then root mean square error, which is like RMSE. Okay, I gave the formulas. It is pretty easy. Okay, and then you can try it out, and then check, and then if at all you don't know it, you can always post a question to my email address that I will be giving you at the end of the session. So here y cap is the predicted value and yi is the actual values. Just remember that, and then you get all these errors. Okay, so time series analysis is all about what do you say is extrapolating, because you know till certain point of time t is the time, that is the current time you just think of. So yt is the current time, and then you can extrapolate it till maybe like yt plus 10. That means for the next 10 minutes you can extrapolate. So there is nothing but you are extrapolating it. Okay, interpolation is basically between the known values. If you want to forecast something, that is we call it as intrapolating. Okay, moving averages is the first known or the best technique from the statistical toolbox point of view, where for the next 2-3 years you will take an average of 3 years to predict the next values. That is what is moving average. So and then yeah, I think like this is what you know it, like if you take t is equals to 3, and then you can start predicting it what happens at 3 equal t y equals to 4. Okay, and then the moving average technique with some kind of weighted moving average that we call. Okay, so now this 1 by k and everything becomes w1. So w1 yt, w2 w3, so on till wk, and all these w's are less than 0, less than or equal to 1. That means it has to vary between 0 to 1. It cannot exceed 1, or it cannot come down below 0. Okay, and then there is a technique called exponential smoothing, because and this smoothing is very important to make I think there is a slide which I forgot what is the name of it. Just a second, I'll tell you. Non-stationary data into a stationary data. Okay, so if you want to bring that non-stationary curves or data into a stationary data by removing all those trends and all, so you have to do apply techniques of smoothing. There are a lot of techniques like exponential smoothing, simple smoothing. I think there is some algorithm which is called Helds or Halls smoothing. I think like we will even see that. So these kind of smoothing techniques we'll apply, and then see how we can cut short the trend, and then make the data more non-stationary, more stationary, and then we will start applying our average methods like moving averages like 3 to 5, or we will even sometime apply deep learning methods like long short-term memory, which is neural networks, and then out of which we can start predicting it. Okay. And seasonality, as I said this, and this is how this seasonality would look like. There are two things: additive seasonality and multiplicative seasonality. So additive seasonality, it is like more stationary in nature. Multiplicative seasonality, because it is multiplying year on year, so you can see the increase in the amplitude. Okay. And trend models and all these are like mathematical formulas, but with this I will, since you know now what do you say, the terminologies of time series analysis, without wasting much time on theory, let's start or begin our practical session. Okay, so let me open up my IDE and then bring it up. Okay, so I'll say my project as time series analysis. Okay. Okay. So we'll put that under desktop, and interpreter will change it. Okay. That's it. So I have a data set which is like gold prices. So from very past, there are some gold prices that are recorded. So you have a date versus price from 1950, which is very long, till 2020, I guess. So for this, we will start analyzing how it looks like and all. So let's put a Jupyter notebook and I'll name it as analysis. Okay. And let us start this. Yesterday you told me to increase the font. Okay, let me do it. I don't know. First import numpy as np. Okay, I think you can see it. Okay, and then import pandas as pd, import matplotlib dot pyplot as plt, import cborn, which is more powerful visualization library, as sns. And here I will start taking some statistical models into consideration. So from stats models dot tsa, time series analysis, tsa dot api, import I told you, right, smoothing, exponential smoothing, simple smoothing, and Holster algorithm we call it as, but I forgot that name, but we call it as Holst. Okay, and then maybe for now what I'll do is I'll take some regression models from sklearn dot dot linear model, import linear regression from sklearn dot neighbors, I think neighbors, import k neighbors regressor. Okay. And yesterday you were seeing, while I was drawing some visuals and all, or day before yesterday, you are seeing that warnings coming in front of the visual. So just to suppress that warnings, import warnings dot filter warnings of ignore. Done. So you see my Jupyter notebook started and this cell got executed. So how do you identify the cell got executed? So a cell is given a number. So if you see this IN1, so after execution only this is assigned a sequence number. If you see this is not executed, so it is not numbered. Okay, that is how you identify it. Now df is equals to pandas dot read csv of, just check this, gold. Okay, df dot head of 10 records, you will see. So this is how the 10 records are showing up. And now what we will do is we'll check this shape, df dot shape, just execute. So we have 847 records with 2 columns in it. Okay. And what we will do is we will check like what is my first date and last date available inside the data set. Okay, that we will check it. So maybe I'll say print. Okay, I'll say formatted string. Okay, gold prices are available from. Okay, so this is a df dot location, and you can actually select df dot log helps you to find out columns. So I'm telling first column till I say date. Okay, and then of 0 in that first selected. Two, you can do the same thing, df dot log location. I'll say colon comma date, but this time you have to go till end. That is 0 is the first of the data frame. Now you have to select the end. How you get it? So you have to take the length. Okay, length of data frame -1. Okay, now you just enter. So gold prices are available from 1950-01 to 2020-07. So that is how you get it. Okay, fine. This is fine. Good. So we will change all these things into monthly range of. I mean, like we'll convert normal dates into monthly format. Frequency is monthly. That's what we consider. Okay. So date is equals to pd dot date range. We have two date time and date range. There are two functions. So for which like we'll pass start is like basically 1/1/1950. Okay, and then end is equals to 8/1/2020, and frequency is basically, as I said, monthly, so we will say yes. Okay, now just print this date and then check. So this is how all your dates comes into picture. Okay, now go ahead and then we will what we will do is we will insert one more column which is called month, and we will drop this date column from the data frame. Okay, so current data frame is basically two, right? Date and price. So going forward it would be month and price, not date. Okay. Okay, for which like you have to do df of month, okay, is equals to date. Okay, the dates that we have computed. So now we will say df dot drop, and there are columns is equals to date, and then axis is equals to 1, and in place is equals to true. So this will we will attach it back to the data frame dot. So for every time series we have to index the date fields, basically our date column, any column that is actually functioning on a date or time. So we have to take that as an index, because based on that index only we will start analyzing like what exactly is happening on that particular day, month, or something like that. So we have to fix the index. Index is basically our month. Okay, and then now just check how it looks like, head of 10. See this, now your date has gone. I said like month would come into picture with the price. Okay, now let's there is a statistical test which is called Eddy Fuller test, in which like we will take the null hypothesis as our is non-stationary, and alternate hypothesis as a stationary. I think like I don't know if you know it or not, but in statistics we have a lot of hypothesis testing. Hypothesis testing is basically used to identify the inferences for a given data. So you assume something and you take that, okay, if not this is not, then the other hypothesis or the other assumption is correct. So that way you will start it, and then you prove that any one of the either alternate hypothesis is wrong or a null hypothesis, which is the default hypothesis, is wrong. Okay, so for which I'll define one method which is called def Eddy Fuller test, and we will pass something called prices. I'm sorry, prices, there is no word price. Okay, and we will say for value comma label in zip of result comma label. Okay, first I have to, okay, zip, this is zip. Okay, so first I have to do what, result is equals to, first I have to compute. Okay, computation with AD fuller of sales. I'm sorry, not sales, price. Okay, so now this AD fuller is not there, so it says import, so we'll import it. Good. And since we don't have a label, so we have to import that labels is equals to, I'll put some labels. Okay, labels is ADF test statistics stats. Second one is p value. We compute something called a p value, z value, t value, different values are there. So number of lags and number of observations used for this test. Okay, so this is labels now, and then this. What happened? Okay, spell mistake. Fine, good. So now we'll say print label plus cr of value. Okay, and then we will say if result of 1 less than or equal to 0.05. Okay, then we will say print something else, print something. Okay, so okay, so we'll say if it is less than this, we'll say reject null, I think hypothesis, and this is accept. Okay, so this is like basically we will say, okay, I'll even put the comments, hold on. So I'll say h naught to be, it is non-stationary, and my h1 basically, which is alternate hypothesis, is it is stationary. Okay, so we are rejecting the null hypothesis, so it should be like it is stationary. Okay, maybe, okay, it is less than this, maybe I have to swap it. I'm exactly in ambiguity, but okay, let's see it what happens. Okay, fine. Now we have to call this method fuller test, and then you have to say df of price. Okay, now if you see this, okay, super. So ADF test stats, so 0.81 and p value is 0.9, number of lags 11 used, and number of observation 835. Reject the null hypothesis. So that means like so it is not stationary. It says like it is not, it is stationary. So yeah, I'm sorry, it is stationary. I mean, like this is like h1, so we say that accept h naught. Okay, I0. Okay, now if you see this, run. Okay, accept h naught, that means uh, the data that is present or given to us is non-stationary data. Okay, so that by statistics you can predict like this, but from visualization also we will see it how it looks like. Now the first visual of the class, so df dot plot, so we'll plot it by fixed size, by putting the fixed size as 20 comma 8, and then we'll say plt dot y label is always price, and plt dot x, okay, x label is always month, okay, and then see this. If you don't even want this particular text here, we will say plt dot grid or show. Okay, see this, see how much data it is, like how it is varying and all. So it's not stationary, basically. That's what we understood. Even my statistics is supporting this, so visually supported by statistics. This is the evidence that you have to give. Okay, and now we will bring up different statistics that are there here. So we have something called df dot describe. Okay, if you do it, okay, too much decimals, so I'll say round it off this to 2 decimals and then execute. Okay, so you have count, mean, standard deviation, minimum of this, 25 percentile of the data set, 50 percentile, 75 percentile, and maximum of the data set. So these are the price values, how they are varying. Okay, now what we will do is basically we will create a box plot. Box plot is the best plot which will give you 5 different indications. One, the outlier, the extreme outliers, the lower and max ranges, and then you have the median of that particular data. Okay, let's code that. So we'll say fig comma axis ax is equals to plt dot subplots of fixed size is equals to, again the same size I'll take, which is like very good fit for my screen. So sns dot box plot, and then you will pass x is equals to df dot index dot year, comma y is equals to df dot values of 0 colon comma 0. Okay, and then ax axis is equals to axis, and then you can actually put some title, x label, y label, how you want to get the x ticks. Basically I'll put it. Okay, first of all I'll plot and then I'll show you something. What happened? Okay, this is wrong. Size d. Okay, so this is how box plot is coming. Now if you see this, all my data of months is being overlapped, or the years are overlapped on each other, because there is too much of data that has been populated. So for which, like, there are some alternates, like we can say plt dot x ticks, and then you can say rotation is equals to 45. So in 45 degrees all my this would be rotated. Okay, if you see this, all my years are rotated in 45 degrees and there is no overlap, and you can see all the data points. Okay, so you don't need this. Okay, so what we can do, plt dot grid or show, anything would work. Okay, see this grid is basically, it will display the grid. Since my theme is dark, you are not able to see it, but there is a grid in the background actually. Yeah, okay, so this is the box plot that you can get. Now this is the the outliers, and then you have the top and bottom, and there is a median of this particular data point. So very informative plot. Most of the statisticians use this to know what exactly is happening in the data. Okay, and now let's identify some repetitions or time series plots, basically. Okay, so from, okay, stat stats models, okay, dot graphics dot psa plots, we have time series analysis plots, in which, like, sorry, import month plot. There is something called month plot. Okay, so again the same thing, fig comma axis is equals to plt dot subplots of, you can say, fixed size is equals to same size 20 comma 8. And now what we will do is a month plot of data frame comma maybe like y label is equals to I'll say gold price monthly and say plt dot grid. What happened? Oh, fine. I did not specify it has to be in the same axis, so it has printed somewhere else. Okay, now you see this. So this is every month. This is how the trend is going actually. Okay, and this is the min values for every trend. Okay, month on month, every month. Okay, so with that, what we'll do, maybe like I'll now since I have kept the code ready for myself, so I'll start putting and then I'll show you. So we will even more drill down into the box plots. See, this is how our box plots look like. This is for the all the values month on month, how the box plot is looking like. Okay, and now we will say average plots. Okay, annual average plot. Okay, so you say df dot resample annually, that means a means annually. So one particular year it will resample and it will take the average of it and then it will show you. So this is how annual plot would look like. Similar we can do which is called quarterly. Okay, if you do quarterly, this is how a trend is looking like. And you can even do something called a decade. That means like for every 10 years, what is the trend that you see. Now you see this 1970, 1980, there is an increase. 1980 to 1990, there is an increase. Again, there is something happened between 1990 and 2000. There is a fall in the gold price. But after that, it never declined. It is always increasing. Okay, so you can treat this as an anomaly. We call this as an anomaly. Something suddenly happened and it fall. Gold price will never fall, basically, very easily. That easily it will not fall. It doesn't mean that it never falls. It falls, but it never that much easily it falls. It drops. So there is something happened in this period which made the gold prices drop, and then it started increasing again. So that is how you can infer some of the insights, basically. Okay, now what we will do is we will basically compute something called standard deviation and mean, and then we will put some tabular form on curve plot, so which is covariance. Okay, so this is how the mean and standard deviation, this is the computation df of standard deviation by mean into 100 and then on round offing it to 2. So this is how it looks like. And if you plot this COV, so this is how it looks like. Okay, so this is how that trend or basically the variation of the data of COV look like. Okay, and now what we do is we will split the train and test data. So what I'll do is maybe less than or equal to 2015 is my train data and greater than 2015 is my test data. And that means like 2015 to 2025 years of data is my test, and then almost 2050 till 2015. No, I think it is how much, what is the starting year? 1950, I'm sorry, not, yeah, 1950 to 2015 is my train data. So we'll see the sizes. So 792 versus 55. Okay, it's okay, decent, but it could be even more, such that like your accuracy will improve. Now what we will do is we will actually plot and see how the training data and the test data are on a single plot. Okay, so this is my, all the blue is my training data, all the amber is my test data. Okay, so now what we will do is maybe we'll create some regressions and then we will see it. Okay, and yeah, I think like we created a k nearest neighbors regression, and then now what we will do is basically what I did here is I started getting the time of training test and the test, because you are actually iterating over the length of the data, and I'm actually putting that as a train. And ultimately what we created is in k nearest neighbors, we kept as a regressions basically, and to some variable, and then finally I'm putting as a LR train and LR test, and then over the time and the price. So over the period of time, how the price is varying, that you will come to know. Okay, so now if you plot that, this is how it looks like. Now if you see, this is the prediction, very bad, right? So the model has predicted it like worst than anything. So there is data, it is happening here, but your prediction is somewhere else. So what you have to do is basically, you have to compute your MAP error. Okay, so to check that, I just wrote this. So if you check this, like it is 97.38, you have to reduce it more. That's what I was saying. If you have more data, you will get it more. But never mind, what we will try to do is now, just a second. So okay, so now what we will do is we will apply something called exponential smoothing and all. Hold on. Yeah, sorry. With the exponential smoothing, we will get this predicted value. So we will treat that exponential smoothing. So out of this smoothing, what we are giving? We are giving this DF. Why are we using exponential smoothing? Because we are seeing some trend and also we have to remove them. So we will say that trend is additive, because why additive? So it is actually growing. Okay. And seasonality, again, I'll say additive. And then finally smoothing level, and then smoothing trend and smoothing seasonality. So everything has to be smoothed out, and this I will treat it as my final model. Okay, once the model is ready, maybe I will choose one more cell to show you how the accuracy will drop now. Okay, now see this 17.24. This is like 97.38. Like this is bloody ridiculous. Okay, now at least like it has came till 17. Okay, now what we will do, we will start doing our predictions over the test data. Okay, so now if you do this and say this predictions, okay, now the predictions are done, and now we will see prediction DF. We will create the prediction data frame also for the entire data set. So yes, these are like upper CI is upper cumulative boundary, lower cumulative boundary, and then prediction. So prediction is always between two boundaries, lower value and upper value. So lower value of a prediction, upper value of a prediction, and the actual prediction. Okay, so now what happens is, now just run this and you see this. So these are, I don't know if how best you are seeing it. There is a pink line that is actually going in, which is the boundary of the actual prediction. Actual prediction is in the amber color, which is the orange color. So the upper value of the prediction, so maximum in the prediction, it can go till here. Minimum in the prediction, in the worst case, it can come down. But this is the actual prediction that the algorithm is telling. So the gold prices would increase in this way. It is what it is predicting. With this, maybe I'll hold off, and then we'll take question and answers, because I think we only have 5 more minutes, but I can stay for the next 5 minutes. So we have almost 10 minutes to take the question and answers. I hope now you understood what exactly is time series. We started with different terminologies, and you know that time series is a combination of trend, seasonality, cycle, and then some kind of a random error. So combining all those things would be your seasonality. If you add all these different patterns, trend plus seasonality plus cycles plus random error, that becomes your additive model. If you multiply all these things like trend into seasonality multiplied by cycles into some random distribution or random trend, so that random values of data, that will become your multiplicative time series or multiplicative pattern or analysis. So additive pattern and multiplicative pattern, these are the two things. So ultimately, when you identify that this is not stationary in nature, so I have to make it stationary by smoothing that. So we applied exponential smoothing. Similar way, you can apply halts and then simple smoothing, and you can see the variation. That is left to you guys. You practice, you take it and you do it. And then we saw a real-time example. I've taken a gold data set, and then we have analyzed it left and right, and finally we have approached at our prediction, where it is predicting for the next I think like next 5 years or something like that. And this is the data that you are seeing live on the board. So with this, I rest it and I give it back to Abid sir, and then we can start taking the questions.
Yes, yes. It was a wonderful session with hands-on experience. So most of the people who don't know what to start, how to start, etc., from your 3 days of sessions, they have got 100% for sure. They got an idea to change or to start a new career in this particular field. So now I take the questions. One question is from Renuka. So she is asking, among all the editors, which type of editor is most preferable? I think you went for mute.
I'm sorry, yeah,
Yeah,
thank you
yeah,
sir.
you can repeat once again.
Yeah, so it all depends on how flexible you are on on using or hands on. So if you are very much flexible with Visual Studio Code, there is one editor, there is a Jupyter, and then I am using IntelliJ, and there is Eclipse also. So it is all dependent on you. If at all like you are well versed with any shortcuts, you can play the editor like anything, so you just choose that. There is nothing like it is good and bad.
Okay. Second question.
Then I am using IntelliJ. Okay.
Second question is from Vijay.
Okay.
Similar type of. Good morning, sir. Can you please share us the link in WhatsApp group to install the application of Python, IntelliJ, IntelliJ, and necessary apps for to perform analysis?
Okay, definitely. Maybe IntelliJ. Right now, I am putting the link inside this Google
Okay, I
meeting
will share.
link.
Yeah.
Okay, which is like to the repository where you can find all these. What do you say? All this code base basically.
Okay.
Okay.
Okay, I will
Just give
share.
me a second. So I'm putting it right away here. Uh, yeah, that is the repository for your polarity workshop that I've created and pushed
Yes.
into the GitHub, and you can find everything there. I
Okay.
think there is still time series analysis is not at kept, I guess, but definitely I'll push it time series analysis also in the next 5 to 10 minutes, and then you can get it from that. So this includes both code as well as data sets. Okay.
Okay.
And coming to IntelliJ, there is no particular link. Yeah, you can go to Google and say IntelliJ download. You will get it as a first link.
Yes. Yes. So Chandra Kumar asking, what is KNN regression?
Okay, KNN regression is basically K nearest neighbor regression. So what it will do is it will always take the nearest values of a given particular data point, and it will form that continuous function, and it will start applying the regression on top of that. So every algorithm is basically classified into two things, again, regression, classification. So whatever you see it for classification, right, that is also available for regression. Okay. So example, let's say you have a decision tree. Okay, you can use decision trees for classification, as well as you can use a decision trees for regression as well.
Yes. Jyoti is saying excellent workshop, sir. And Dr. B. Jani, excellent program. Dr. Jagdish R. Mahida, very useful sessions. Dr. Jitendra Kumar, well explained, sir. Nice session. Next, Salil said, well explained. Shalini, nice explanation. Chandra Kumar Renuka, one question. What is exponential smoothing?
Okay, so okay, very very tough question. Really, okay, really, it's a very tough question. The reason being is you need to understand a lot of statistics behind that. Because of the time, I couldn't explain you, but there is a formula that is actually there, and by applying that formula, what happens is maybe like I am not going into the details of the formula. Just imagine that there is one formula for that exponential smoothing. What happened is when you draw the raw data, okay, you may see a lot of trend of the curve going up down, all those things. But after you apply that particular procedure or the formula for that given data, so your data set will be transformed to something else. And if you start drawing this data set, the new formed data set, you will see that curve has come down and it will become very smooth in nature. Maybe Okay, just give me a second. I'll show you something now. Hmm. Okay, maybe I'll show. Okay, um, just a second. Okay, let me share my screen back, and I'll show you something. With that, like I think I'll answer a little bit, but not completely. Okay.
Okay.
Just let me know once you are seeing the screen.
Yes, yes.
Okay, this someone has written an article in LinkedIn. Okay, so this is like a very good article. So they have used something called simple exponential smoothing. Something, your question is on exponential smoothing. It could be like simple exponential smoothing or halls or some exponential smoothing, normal exponential, ordinary exponential smoothing. It is based on exponential smoothing. So what happened now, you see this is the actual data demand. Okay, and the green dot is forecast. Now this orange is basically a forecast that I think like he has done with the smoothing. So now what happened, he has applied something and your curve, so there are spikes like anything, right, that has got smoothened down if you see this. Okay, still at the time of your spike only, this is also spiking up, but it is not spiking like very sharply and coming down, but it has smoothened down. This is what is smoothing techniques will do. Okay, it makes your curve come down and make it more stabilized. Hope that answer it. But you
Okay.
have to do little extra work,
Yes.
like just maybe go through some articles, or maybe like just you can even ping me on LinkedIn or something like that. Maybe I'll give you some context way how actually that is being done.
Okay. So next is next question. Sirisha. She is continue. She is asking, sir, is exponential smoothing done mostly on addition or multiplicative?
No, it is basically dependent on problem statement. So to apply smoothing techniques, first of all, you have to see whether your curve is actually going towards additive kind of data distribution or multiplicative kind of a data distribution. Based on that, you can actually apply smoothing. Smoothing is basically, you can't tell, okay, my exponential smoothing gives me a better result, or a halls will give you a better smoothing. It is something like you have to check. It's like a permutation combination. First you check with additive. Most of the time, if there is no seasonality, I guess if there is no seasonality, then we go for an additive. If there is a seasonality, then we go for a multiplicative. And then once you find out both the things, then we'll start applying the smoothing techniques on top of that. So it would be like, first of all, you have to identify what is exactly happening in the inbound data, that is your actual data. And then on top of that, then you decide like what kind of a smoothing technique that you have to apply.
Okay. Next question is Madhuri Kumari, she is asking, over what time series we can expect our model can give accurate value?
Can I get the question again?
Once again, over what time series we
Okay.
can expect our model can give accurate value?
Hmm. There are a lot of time series algorithms, that what I said. Example, arima, moving average, and then regression combined, like moving averages and regressive analysis. I exactly forgot the definition, but yeah. And then you have serima, okay, which is like seasonality inbuilt into it. And then you have deep learning mechanisms like LSTM, auto encoders, okay. So again, the same point, no, which type of time series analysis will give you a very good result. You cannot actually tell that. You have to experiment with different things. And if you see what we did it for linear regression. My error MAPE, that probabilistic error, mean probabilistic error was like, it was like throwing me out like anything like 97. And you saw even my prediction line was at bottom level, which is like bullshit and rubbish, right? So the way data was above, and then my prediction was way below it actually. So then what we did, we immediately changed. We applied smoothing technique, and then we made the data more stabilized in nature. Then we applied the data, the prediction again, and then we saw the error came down to 17. Now what you can do is, after smoothing, then you may fit into some other algorithms like like LSTM, which is like more recurrent in nature, like with lot of deep neural networks and all, that you can try out. Or you can try with some other algorithms like bagging and boosting, which are ensemble methods. And then see how your error, basically the main motto of any machine learning algorithm is just minimize your error, right? So the best or the minimum, the localized minimum error which algorithm is giving you, that you can take it as the good algorithm for your use case. And for that particular algorithm, you start fine tuning very more, such that like your prediction accuracy goes to a very good level. So in a single shot, we cannot tell this is the algorithm, you go and use it, no.
Okay. Dr. A. Naresh, which one will give the best accuracy rate, sir?
Again, same question, right?
Same question. Yeah.
Same question, same answer.
Bimala is saying a good explanation, sir. Madhuri Kumari, do we have to train the model frequently with the new data?
Absolutely, very good question. Actually, excellent question. So, so the model which I trained is actually very good for the next maybe, if at all your data is too much high streaming data. That means, example, you take stock data. So for every minute, I'll get lot of data, right? And then for a day, you will have a millions and I think like terabytes of data I can collect in one day. So a model that is trained for at 9 o'clock or 10 o'clock will not hold good for 12 o'clock. That means in 2 hours of time frame itself, your model is gone for toss. So that we call it as data drift, okay, or a model deviation. Okay, so there are some techniques basically which we follow for identifying how your model is behaving over the time, and what is the data drift that is happening from the trained point till current date. If the data drift deviation is too high, then definitely there is a requirement or a want that you have to retrain the model immediately, and then keep the model up to date with the latest data that is incoming or already came and then sustained into your databases. Yes, there is
Yes.
always a need for retraining.
K. Prashant Kumar, what is training data and test data? How we have choose the percentage of data, that is 80% and 20%? Please elaborate.
Okay, training data and test data is nothing simple. Okay, out of the complete data set that you have, we will divide some portion of the data, saying that okay, this is my data which I will train on the model, and we will put some other data. I will say that this I will not expose it to the model. That means model will see that particular test data for the first time when we start predicting it. That is how we will actually create the errors. Okay, so how do you validate an error? Because if you train a whole model at a whole data at a train, what will happen is your model will overfit. So that will, it will learn everything, but for a new data point it will start failing. Okay, so for a given data it will start absolutely giving results like 99%, 100% like that, which is like overfitted. So this is what is training and test data. But coming to the ratio, right, it is general rule prescribed in all the textbooks saying that if you have 100% data set, take like 70-30 or 80-20 rule. Okay, like 70% of the data is your training data and 30% for your test data, or 80% of the data is training and then 20% of the data is testing. It is like a standard or recommended way from a well-known data scientist or something like that. So we will actually adhere to it and do it. So maybe like you
Okay.
can, if at all you are trying to do some kind of research, you can do it like 50-50, 60-40, and then you see like what is happening with the model. Okay, at what position you are getting accurate results, maybe that you can fix it as your ratio, you can do it. But time matters, and already people has told that okay, with this kind of differentiation or division you get dominant results, so that we follow.
Yes. So next, Azmal SM saying useful session and build confident on us. Thank you, sir. Chandrasekhar saying the journey of 6 days were very good, well planned, and last three were awesome. Hands-on session, superb surgery. We need to have more like these sessions. Thanks a lot. And Lakshmi Nelluri, she is asking training data to validate the data set. I think it's an incomplete question. So Chandrasekhar Renuka asking, does smoothing removes outliers?
No, smoothing will not remove outliers. Outlier removal has to be done as a pre-processing of your data. Smoothing will just remove your cycles and trends and seasonality from the data set. It will not remove the outliers. Removing is a special step that has to be done as part of your pre-processing of the data.
Yes, yes. Writing most of the questions are compliments. Almost. Yes, we got most of the comments or compliments. So as time is running out, so hence I conclude today's session. So from our GPREC and on behalf of our department, I congratulate all participants to for attending successfully this 6 days workshop. And also I am very much thankful to our resource person, Mr. MK Pawan Kumar, sir, for accepting our invitation and spending your valuable time and sharing your knowledge. Thank you very much, sir.
Thank you very much to you all.
Thank you. Thank you. So I need to continue. I will take some 15 to 20 minutes of session of the day 6. So, sir,
I think like yeah, I'll
yeah,
drop off. All the
yes,
best, guys.
thank
Enjoy. Maybe I'll give all the resources to Abid sir after
yes,
some time. I'll give him in the WhatsApp. I'll send him all the
okay,
materials like presentations and all those things. And the code is already pushed. The time series code is already pushed into the GitHub. You can actually access and you can get it
yes,
from there. Thank you, guys. Enjoy. All the best.
right, thank you. Dear participants, actually, day 6 session was mine, but as our resource persons are, he asked me to provide one more session. So I can't extend this FD workshop to 7 days, as it is planned up to only 14th. Hence, time is running. I will take my sessions very quickly, and the certificates, those who filled the feedback form, the certificates will be sent within a week to the participants whose attendance and quiz is more than 60%. So let me summarize the things. let me go with this applicative part of this artificial intelligence. What is actually, and before starting my session, I will just share you the information that most of the people they are asking that as AI is coming, our jobs maybe in future most of the jobs will lose. So I will simply to answer to give the answer for this particular question. I will just simply one one story I will tell you. If you observe some 100 years back or 150 years back, there are no vehicles. Peoples are traveling using animals or by walking. Okay, so the transportation system is they use some type of animals. So to maintain those animals, there are different jobs. There are different jobs to maintain the animals, the horse rider and the maintenance to maintain that horse. Some another people is required, the place is required to to have the small place for that particular horse riders, etc. So different jobs opportunities were there when the horse, whenever the with the development of the technology, whenever two wheeler or vehicle became commercial, at that particular time the people who are maintaining the animals as a transport, they lose their jobs. Obviously they lose their jobs. Couple of people, sir, more than two or three people who are maintaining those systems, they lose their jobs. And they thought that instead of three people we need only one person is required, that is to drive the vehicle. But actually if three people are losed their jobs previously, new jobs created with the invention of this four wheeler or two wheeler technology are petrol pumps, the people who are working in petrol bunks, the petrol transportation system, and then the mechanics, those who are needs to to provide service to your vehicle for regular maintenance, the music system peoples, etc. So if you count, if three people lose the jobs previously, with the invention of this two wheeler or four wheeler vehicle, more than three, at least double of the people has got the job. New opportunity has been was created. In the same way, this may case will happens to the applications artificial intelligence, as art, AI is doing most of the human works now, but without human being alone, AI cannot be we can't get our services. So hence, as the number of users are increasing day by day, so new opportunities may create. So hence, now I will conclude my session in a quicker way. Applications of artificial intelligence. So most of the cases, what are the cases where this AI is used? So first of all, what is AI? Artificial intelligence is the ability of a machine or software to perform tasks that normally require human intelligence, such as learning, reasoning, and problem solving. A human mind always, in the form by observing something, always human mind is learning new things. Human mind will ask why. You observe the children, for every, as they are in the learning stage, for every point of their movement, they will ask why, reasoning. So our human mind is reasoning. It will ask the reason to accept the reality and also the problem solving. So in the same way AI will works. AI is a broad field that that has many disciplines, including computer science, data analytics, statistics, hardware and software engineering, neuroscience, and philosophy. There are many types of AI, but most AI systems fall into the following categories. That is, one is machine learning, another one is deep learning. Machine learning algorithms learn from data and improve their performance over time without being explicitly programmed. Suppose, for example, I am saying a machine learning algorithm can be trained on a data set of images of cats and dogs and then used to identify cats and dogs in new images. That's it. Very simple. And similarly, deep learning is a type of machine learning that uses artificial neural networks to learn from data. Artificial neural networks are inspired by the structure and function of human brain. That's it. And they are able to learn complex patterns from data. The deep learning algorithms are used in a wide variety of applications, including image recognition, natural language processing, face recognition systems, and machine translations. This artificial intelligence is used in many different industries and applications, including it is useful in technology. AI is used in a variety of technological technology products such as search engines, social media platforms such as Instagrams, Facebook, and self-driving cars. Healthcare. AI is also useful in healthcare. AI is used to develop new drugs, treatments, and diagnosis, and provide personalized care of patients. And also, AI is used in finance. AI is used to detect fraud, make investment decisions, and managing risk. It is also useful in retail. AI is used to recommend products to customers, optimizely supply chains, and prevent. For example, Flipkart and Amazon. And it is also useful for in manufacturing. AI is used to automate tasks, improve quality control, and predict the demand. And most of the examples of AI are self-driving cars. An AI algorithm are used to control the self-driving cars, enabling them to navigate roads, avoid obstacles, and obey traffic laws. Virtual assistants such as Siri, Alexa, use to understand and respond to human speech. Spam filters. In spam filter also, the AI is very much useful. What we observed in our daily life. And in the same way, fraud detection also AI is useful. In the case of fraud detections, AI is mostly useful. AI is a most powerful tool. I can conclude that AI is a most powerful tool to improve our lives in many ways. Now, AI, I can say another one. AI won't replace doctors, but it will augment them. That is the point here. So making AI work, these are the some problems. So the solution is understand the foundations of AI and then evaluate the latest trends. Some of the definitions given by our previous mathematicians is this is the art of creating machines that perform functions that require intelligence when performed by people. It's a simply the art of creating machines which are going to perform just like us only. Now, I'm just making. So these are the some six disciplines that are major research is going on. That is NLP, natural language processing, knowledge representation, automatic reasoning, machine learning, and computer vision with robotics. Okay. Now, the foundations of AI is philosophy, mathematics, economics, neuroscience, psychology, and computer science. I hope you can. These PPTs will be available. I will share you later on. And also one more is control theory and cyber cyber nets and linguistics. These are the some good resources available here. So if coming to the history here, 1943 is the foundation of this particular AI platforms. 1949 Donald Hebb invented influential Hebbian rule to update neural connectivity, and similarly 50s. What but I can say John M. Cutty, he is the father of AI, and the rest research is going on till today. 1958 John M. Cutty invented LIPS programming. LIPS programming. And 1958, same invented one more project named as Advice Tracker in the same way, 1959, and solve the problems on GPS. So in this is the just I am just moving on as being time factor. So 1966 possibilities created a hype but failed to attempt. Similarly, 1973, 1976, and 1972. Prologue. You may have heard about this prologue. Just give me a minute. Let me share my screen. I think it's not movable. Yes. Now, so let us see here. So coming to from 1980s, Lisp machines were costly when compared with general purpose machines. Sun, Apple, IBM people. Early 90s, expert systems were costly to maintain and unable to extend the learn. In 90s, machine learning played a key role in building the efficient internet tools like search engines, recommender systems, and fraud detection. In 2001, Banco and Bill shows that Medicore algorithms when trained on 100 million samples outward best algorithms. It means that I'm told it's a group of proof that GPU can solve the computational bottleneck using big data. This is the brief history of this AI since 1950. So these are the areas the area is contributing, that is philosophy, mathematics, economics, neuroscience, psychology, computer engineering, control theory, and chemistry. Some of the applications of AI I am showing here. That is Leobird's project Revise, Voice Base, and Spice. AI will be 100% useful in transportation to navigate yourself. It is also useful in gaming, and also it is useful in autonomous vehicles. It is also useful in recognizing the faces on the in the images. It is also useful in sensing peripherals in playing the sports games. And also it can be used give recommended. It can be act as a recommender systems for most of the e-business companies, that is Amazon, Flipkart, and Netflix. It is also useful in biomedical patient similarity matching. Based upon that one, can predict the risk of patient disease. It is also useful in stock markets also. Most of these algorithms may be useful. Social media, there is spam filtering, advertisement display, and many more. This is the one of the NVIDIA BB8 model car which has been developed using AI. And of course, obviously, for robotics application, most of the robotics application uses AI models. And also, this is one of the things Solo combines facial features, means based upon our facial expressions, it can read out the emotion of our face, and based upon that one, it will play. Also, for image comparison, complete captions it can provide, image classification, some of the image or object classifications. There is a difference between image classification and object classification. And also analyzing faces with face services such as happiness, color, etc., age, etc. We can move. Reading with the computer vision services like this. And these are the some of the textbooks which you can prefer later on these things. So I request all the participants to uh, go through these sessions in your these sessions will be available in PPT. So the resource persons who are going to share me their PPTs, codes, etc. I will share with you in the WhatsApp group. And here is the end from my side. Due to time factor, it's already half an hour late. So hence I am just made the things very fast. And if any of the students, if you have any of the participants having any query, you can post your query in the chat window. So I will share one more small slide here. So these are the job opportunities in this field here. So if anyone here interested, you can make clear field, choose a particular field, and develop your skills by attending the workshops such like this. So if, let me see any queries. So most of the participants are saying, when will get the certificate? Of course, so within a 1 week you are going to get the certificate. And now, thanks to the organizer and experts of this FD for well planned and well conversation lectures. Thank you very much. So I thank all the participants today, as we have taken an half an hour extra, but as our resource persons insisted, means requested me to provide one additional sessions as his topic is more. Hence, I provided my time to him. But anyhow, I just made you clear about the. I will share all these PPTs later on in the WhatsApp group. Thank you very much. So certificate will be issued within a week. Certificate will be issued within a week. So here is the end of my session. So now let me take privilege. Let me brief as being. Let me brief about the re- report. Now I take it a privilege to give brief about a brief report about the workshop. So this workshop is started on 9th of October. So our respected head of the department, Dr. K.C. Gauri Madam, inaugurated the workshop. And then Miss Preeti Shinde, senior engineer from NOR BREMS Technology Center, India. She was the first day one resource person. She explains clearly about how digital twins and artificial intelligence revolutions revolutionized practical automation in Industry 4.0. Now in the day two, that is on 10th, Mr. S. Bhagat, principal data scientist, Halliburton, he explained clearly about the fundamentals of artificial intelligence, unlocking the future of AI, AI's role in industry, and AI's role in making the career opportunities. Now in day 3, Mr. Pranav Bhargav, decision science manager, Squad Stack, clearly given the demonstration about estimating and managing data science projects. Now from day 4 onwards, regression and classification concepts with real-time use case has been explained by Mr. M.K. Pawan Kumar, applications architect and data scientist, Honeywell Technologies. In the day 5, that is yesterday, 13th of this month, same Mr. M.K. Pawan Kumar explained practically how to use cloud to develop the developed models. That was the very interesting session. Now today, day 6, the time series problem and methodologies to solve it has been explained practically by Mr. M.K. Pawan Kumar, applications architect and data scientist from Honeywell Technologies. Thank you, sir. And finally, myself explain about the applications of artificial intelligence and the job opportunities in the field of IT. Now, I take it a privilege to propose vote of thanks, and I request all the participants. I have once again shared the feedback link in the chat window. Please submit the feedback link and also attempt the quiz. You will get the certificate within a week if you got more than 60% in quiz and 60% of the attendance. I feel it privilege to thank each and everyone for attending this 1 week international level workshop on introduction to artificial intelligence during 9th to 14th October 2023, organized by Department of Electrical and Electronics Engineering in association with NI LabVIEW Academy of GPREC, Department of Emerging Technologies in Computer Science, and Department of Electronics and Communication Engineering. First of all, I would like to thank all our resource persons, starting from Miss Preeti Shinde, Senior Engineer, Nor Brems Technology Center, India; Mr. Bhagat S., Principal Data Scientist, Halliburton; Mr. Pranav Bhargav, Senior Data Science Manager, Squad Stack; and Mr. M.K. Pawan Kumar, Applications Architect and Data Scientist from Honeywell Technologies. Also, I thank our Honorable Chairman, Sri P. Subbareddy Garu, for supporting financially. Thank you, sir. I thank our principal, Dr. B. Srinivas Reddy Garu, for providing logistics. Thank you, sir. I thank head of the Triple department, Dr. K. Sri Gauri Madam, for her continuous support. I thank head of the ECS department, Dr. R. Praveen Sam, sir, for his continuous support. I also thank head of the EC department, Dr. S. Nagaraj Rao, sir, for his continuous support. Thank you, sir. I also thank all the HODs, professors, in charges of various cells of our college, and faculty members. I thank to the co-conveners of this FDP, Sri K. Srikant, Associate Professor of ECS Department; Sri A. Vishnuvardhan Reddy, Associate Professor of ECS Department; Dr. S. M. Shamshir Dola, Associate Professor of ECE Department; Dr. B. V. Arun Kumar, Assistant Professor of Triple Department; and Sri K. Harish Reddy, Assistant Professor of Triple Department, and all the organizing members of this FDP for their efforts in making this FDP a grand success. I thank all the participants for attending this FDP, and I thank those who supported directly and indirectly in making this FDP a grand success. Thank you very much. Here is the end of today's session and end of this workshop. Thank you very much.